Hi, Professor. Good afternoon, good evening, whichever time you're in this. My name is Hector Bocanegra. My teammates are Andrea Barragan, Dylan Baker, Juan Cervantes, and Octavio Duran. And this is our presentation on our prosthetic hand project. In this slide, I'm going to talk about the main purpose of this project. This project aims to take the model you are seeing here, which I'm going to talk about it a little bit later together with Octavio, to pick up information and figure out a way to send it to the user's brain to be received in the same way we do with our regular skin. Basically, the purpose of our project is to replace a missing part of the body or to make a part of the body work better. In this other slide, I'm going to talk about the research we do on prosthetic hands. A prosthetic hand can improve your quality of life by allowing you to engage in many of the same activities you participate in before the loss of a limb. When it comes to functional prosthetic hands, these devices can give you a varying range of motion and control of movement depending on the type of prosthetic hand you can receive. Prosthetics with fingers that can move individually represent the forefront of emerging prosthetic hand technologies. Creating a prosthetic hand is not an easy task. As every project created, the one of ours needed of a core, something that could prove to be functional and could work to us as a base to start from. We needed a perfect design, and selecting the appropriate one will be our first step as a team. The first day when we started to work on the project, we conducted an extensive research to find out the most appropriate design for what we had in mind. Doing our research about the most appropriate design, we found out something named the Raptor hand, a design that was developed collaboratively by engineers of an organization named Enable. This organization states that they created this design with an ease of printing and assembly in mind. Enable establishes three principal objectives of their design, which are the following: to simplify fabrication and assembly and repair for makers and recipients alike, to provide a reference design for future innovations, and identify a core feature set and standardized dimensions embodied in accessible 3D models. We thought this was the most appropriate design for what we had in mind because, as Enable intentions of created this design states, they created it to provide a reference to future innovations. So we had something that could work to us to work freely and do the required improvements. And now I'm going to let talk my classmate Octavio.
Once we had the design, we could start working on it and think about ideas to change the design and improve it. In the meetings we held after deciding about which design we would use, we would split the work of the hand. At first, we thought of dividing the work in smaller teams, but then we realized it was more optimal that each of us worked on an individual basis. Our principal objective is the project was to optimize everything as part of this. The most convenient thing for the project was that each one did a part of the design, as would be too time consuming to wait until the other teams were available and start working together. As just has been established, the center of our project was the optimization. Every decision we took was to favor this idea. We were looking to do something that wouldn't take time away and other resources, yet still being functional. One of the first things we came out was to eliminate the joints in the figures of the raptor design, and instead do single fingers to compensate the change we just made, and it decided to give a curvier shape to the fingers, facilitating the gripping with the hand. After implementing this change to the hand, it was when we just thought beyond the design and its guidelines. We thought about the people that might use our hand. This new approach would help us to do proper improvements to the design we selected as base. Not all disabilities are the same, and we noticed this flaw in the raptor design. To fix this thing that we have detected, we decided to remove the thumb from the hand apart from it to make it easier to create the hand. With removing the thumb from the hand, we were making it, and in that way, we wouldn't need to adapt the hand according to each disability. With this new approach, we came out, we think what the most ideal thing was to develop a hand aimed to help people to do easy tasks instead of creating something for a day-long use.
Hello, my name is Dylan. I'm going to go over the design of the hand here. So on this first slide, the picture on the left, that's going to be the finger, obviously. And then right there in the center next to it, that's going to be the backhand plate. And then the two photos on the right, that's for the back of the forearm. So the idea of this design is on the photos on the right, you can see that plate on top, and it has these little knobs on the back. So right there, you're going to have a kind of a tension line that goes from each of those knobs to the holes that they correspond with, and then they're going to keep following through to the back of the hand. They're going to go through the back of the hand. There's a 1/8 inch hole that goes through it all, and it keeps following it all the way till the finger. Underneath the finger, there's a little notch in it as well that actually that line will attach to. And then on the back of the hand, this is going to be another tension line, and this one's actually going to be similar to a hair scrunchie, that kind of material. So it's flexible, and it can be able to pull the fingers back. So those secure to the top rail on the back of the hand, and those also go through the finger and actually attach to the top of it where you see that little lip sticking out. So that's what we're going to go over on this slide, and then I'm going to elaborate more on the next. All right, so for the second slide, we can go a little more in depth with it because we see the whole model now put together. So we see that there's only 4 fingers, the hand piece and the forearm piece. And if you can imagine the lines attaching from the forearm piece, going through the hand, and then through the finger, and from this angle you wouldn't actually be able to see any of that. The only thing that you'd be able to see is the line going from the back of the hand to the top of the finger. So whenever you have this, and this is more ideal for somebody that doesn't have, basically that they're just missing their fingers. So they still have their hand, obviously no fingers, and this kind of design is just to help them with their daily life. So you attach this to your the back of your forearm, the back of your hand, cinches down, and then anytime you bend your wrist forward, those lines that are running through the hand actually close the fingers, and then whenever you relax your wrist, the lines that are on top of the fingers to the back of the hand, those are, because they're tense, they're going to pull the fingers back because you're relaxed. Now the photo on the right, these are the dimensions that we went with. I kind of put a lot of dimensions in because there's a lot of pieces. Obviously, if you're making this, I would probably want to do this on different angles as well. But you can see on on the back of the hand, how you have the 2 slots on each side, or the 1 slot on each side, 2 in total because you have it on the back of the forearm as well. So those are the slots that you're going to have like a Velcro strap, something simple that secures the back of the forearm and the back of the hand in place. And then we also have a connecting rods. And what we did is put a solid connecting rod through the fingers. Now, if you ever need to replace a part, it's simple. You just slide it out, put a new one in, slide it back on. Also, the reason why we decided to go with just the 4 fingers is it's ambidextrous. So it doesn't have to be specific to somebody that's missing fingers on their left or right. So that way, it's just anybody can use it. Also with this design is you can actually take fingers off. So let's say you're missing your right index finger and middle finger. Now you'll take those 2 off, leave the other 2 on, so you could actually have just slightly more assistance. You wouldn't have to have all of them on.
What we learn as a team. To understand the benefits of teamwork, we need to consider how long it would take us to make the project alone. Now, let's think about how long it would take to finish it if we work as a team. The main idea of learning to work as a team is to make efforts to reduce the time to complete tasks, while increasing the effectiveness of the results. It is important to know that throughout our lives, teamwork will help us achieve common goals, and this fact could significantly influence us in a positive way. Not to mention that it's proven that companies that are based on teamwork are much more effective than those that don't consider it a primary issue or that should be given interest. However, those workers are more motivated and adaptable. We were able to set a clear objective to avoid errors due to confusion, affecting the productivity of the group. We also established a method of communication to provide quick solutions to the different problems we had throughout the project. Also, we established the levels of responsibility of the entire team, see what each one would do and help if needed. Another important point is listening to the opinions of team members. Thus, it is possible to know the reason for the inconveniences and the weaknesses that affect the equipment. In this way, we can make group decisions to avoid disagreements or conflicts for not being taken into account. Although we didn't know each other in person, we all gave our best and at the same time acted with respect and responsibility.
Hello, my name is Sandra Barragan, and I'm going to explain the conclusion. The conclusion has a little bit of how was the process to end up here. I'm gonna explain as a team like how we did it, how we felt about it, and what we faced during this process. But first, I think I have to explain just in a few words, just for a better understanding, just to be clear, the difference between AutoCAD and Inventor. So Inventor is a 3D feature-based parametric modeling design application. It is customized to have only a 3D mechanical design capabilities, like standard part design or plastic part design and others. AutoCAD is a software application that we can also create a 2D or a 3D drawings and models. But AutoCAD, in my opinion and my teammates' opinion, AutoCAD is a way more harder than Inventor because AutoCAD, there are too many tools and commands that you have to learn to create just a basic draft. And basically, that's why we chose to use Inventor, because it's more faster to work on it. And according to me and my teammates, we gained the experience to solve this type of final project because during that semester we were doing homeworks that basically were to implement the new commands and methods to design objects in 2D or 3D. So we have learned the steps and methods to use AutoCAD and Inventor. And for our experience using these two types of software programs, we chose to work using Inventor because we thought it would be easier, and I think it really was.